Okay, this is problem 1 from the non-calculator part of your study guide. And the first couple of problems, there's some typos because we have not learned cosecant, the integral for cosecant. So I want you to change this to this problem, the integral of 2 sine x plus 3 cosine x. Okay, so when we work this, I know any constants that are out in front, I could bring that out in front of the integral sign. And the integral of sine x is negative cosine, so this is going to be negative 2 cosine x plus, again, this is just a constant out in front, so that constant will stay there. And the integral of cosine is sine, so it's going to be 3 sine x plus c. We need that plus c because it is an indefinite integral. Okay, number 2, same thing. We have not learned the integral of tangent yet, so I'm just going to have you omit this one for right now. And that will come in a later section, in a later chapter. Number 3, solve the differential equation g prime of x equals 6x squared, and then they give us this point, g of 2 equals 10. So anytime I have the derivative and it says solve the differential equation, that means instead of g prime of x, my answer should be g of x equals something. So how do I get from g prime of x to g of x? Well, we know we should integrate that. So I'm going to integrate 6x squared dx. And I'm actually integrating this side too. When I integrate g prime of x, which is the derivative, then I get the original function back. So g of x equals 6x cubed over 3 plus c. And now they want me to actually solve for c, and that's where this ordered pair comes in. I have the ordered pair 2, 10. So I'm going to plug 10 in for my g of x, or my y. This is actually 2. And I'm going to plug 2 in for my x. Okay, so I have 10 equals 2 times 8 plus c. So 10 equals 16 plus c. That means c must equal negative 6. And my answer is what I get when I plug that c back in. So my answer is g of x equals 2x cubed minus 6. Okay, so anytime they give you the derivative with a point, we're going to integrate, solve for c, plug that c back in. Okay, number 4. Consider the function f is continuous on the interval from negative 5 to 5, and for which 0 to 5, the integral, is 6. Evaluate the following integrals. So from 0 to 5 of f of x plus 2. Well, I could separate this into 2 separate integrals. I can say the integral of 0 to 5 of f of x plus the integral from 0 to 5 of 2. Okay, well, we know what this is. From 0 to 5, that is 6. Okay, so this part right here was 6. And now I can either sketch this out and find the area under the curve, which is going to be a rectangle, or I could actually integrate this. That's going to be 2x from 0 to 5. When I plug my 5 in and then plug my 0 in, I get 10. So this area was 6, this area was 10, and when I add those together, I get 16. Okay, part B says find the area or the integral from negative 5 to 5 of f of x, where f is even. Well, look what they've told us. They've told us that our function is continuous from negative 5 to 5, but they only gave me the integral from 0 to 5. So the area from 0 to 5 under that curve is 6. Well, we should know that even functions are symmetric about the about the x-axis, about the y-axis, sorry. So f is even, so that means it's symmetric about the y-axis. So if I know the area from 0 to 5 is 6, from negative 5 to 5, that means it's just double that. So my answer is 12. Now, negative 5 to 5, where f is odd. Odd functions, an example of an odd function, that's ugly, is x cubed. So you see, like from negative 5 to 0, okay, this area, do you see that their areas are going to cancel each other out? So my answer would be 0. Okay, number 5, evaluate the definite integral, negative pi over 6 to pi over 6 of cosine. So first I'm going to integrate cosine, which is sine t, from negative pi over 6 to pi over 6. I'm going to plug those values in. So sine of pi over 6 minus the sine of negative pi over 6. So the sine of pi over 6 is the same thing as 30 degrees. Sine of 30 we should know is 1/2 minus negative 30 degrees is in this quadrant right here. So all students take calculus. All right, so the only thing that's positive here is cosine and its reciprocal. So I know it's still 1/2. Okay, the sine of pi over 6 is 1/2, but then I just have to figure out, is it positive or negative? Well, sine is negative in the fourth quadrant, so it's minus and negative 1/2. So my answer is 1. Number 6, evaluate the definite integral of sine x. So these are just basic integrals. The integral of sine x is negative cosine x from 0 to 3 pi over 4. So I'm going to plug those in. Negative cosine of 3 pi over 4 minus a negative, so plus cosine of 0. So negative 3 pi over 4. So I know my reference angle has to be pi over 4. 3 pi over 4 is over here. So all students, okay, 3 pi over 4, what is that, 135? So I'm actually finding the cosine of 135. All students, cosine is negative here. And 3 pi over 4, it should be negative square root of 2 over 2. Plus cosine of 0, we should know that the cosine of 0 is 1. So my answer is square root of 2 over 2 plus 1. And you need to be able to do those without your calculator and without your chart. Number 7, multiple choice, evaluate the indefinite integral of secant squared x minus 2. Well, we should know, because secant squared x is on our list of integrals that we should know, secant squared x is tangent x. Minus, when I integrate 2, I get 2x plus my c. So my answer should be, what is that, B? And by the way, there's a typo right there on multiple. That's okay. Number 8, evaluate the indefinite integral. So this is a u substitution problem. So my u is going to be 5x squared plus 1. My du is 10x. I have my x, I'm missing my 10, so I can put my 10 there as long as I put the 1/10 out in front. So I have 1/10 u squared, because this was my u. Here's my du. So now I'm going to integrate. I have 1/10, add 1 to my exponent, divide by my new exponent, plus c. Now I'm going to substitute my u back in. 5x squared plus 1, all raised to the third power, plus c. Number 9, this is fundamental theorem of calculus, that second part. If f of x, so this means the antiderivative, they want to know what is the derivative of that. Okay, well, if I'm finding the derivative of the antiderivative, remember the rules. I have to have a constant here and my x up at top. If that happens, all I have to do is substitute my x squared in for my t. But then if it's anything other than an x, I have to multiply by the derivative of that top. And so my answer would be 2x times the square root of x squared plus 3, which is C. Number 10, evaluate the indefinite integral. Again, this is a u substitution problem. My u is t to the fourth plus 5. My du is 4t to the third. I have everything I need except for my 4, so I can put my 4 there, put my 1/4 out in front. So when I rewrite the problem, I have 1/4 u to the 1/2 du. Now I'm ready to integrate 1/4 u to the 3/2 times 2/3 plus c. So that's going to give me 1/6. Substitute my u back in to the 3/2 plus c. Okay, number 11. Evaluate the indefinite integral, another u substitution problem. My u is 1 plus x to the fourth, which means my du is 4x to the third. I have my x to the third, but I'm missing my 4, so I have to put my 1/4 out in front. When I rewrite this problem, this is my u, and I have to move my u up to the top, so it's u to the negative 2 du. When I integrate, I get 1/4 u to the negative 1 divided by negative 1 plus c. So I'm going to rewrite that as negative 1, 4 is on the bottom, and my u is on bottom. And so I have negative 1/4, 1 plus x to the fourth plus c. Okay. Number 12. Number 12, find the value of c guaranteed by the mean value theorem for integrals for the function over the given interval. Now this had a formula that went with it. It's been a while. Here's the formula. We're going to use the integral from a to b of my f of c, or f of x dx. And that's going to equal f of c times b minus a. So if you forget what you're going to do, just do this in order. So the first thing I'm going to do is I'm going to find the integral from a to b. So I know from 1 to 3 of 9, and I'm going to go ahead and write this as 9x to the negative 3 dx. Okay, so I'm going to go ahead and work that. So that's going to be 9x to the negative 2 over 2. And I'm going to rewrite that so it's easier for me to evaluate from 1 to 3. So I have 9 over 2 times 3 squared, so that's 2 times 9, minus 9 over 2. So that's 9 over 18 minus 9 over 2. So that's 1/2 minus 8 halves. So I get did I plug the wrong one in first? Plug my 3 in, so 3 squared is 9, 9/18. So 1/2 minus 9 halves. And I get negative 8 over 2, or negative 4. Did I do that right? Negative 9 halves. 9 over 18. Hang on, I'm looking at this. 9, that's going to be 2. Oh, because this is divided by negative 2. I knew my sign was wrong. So I'm dividing by negative 2 here. Here, wait, I'm going to start over on this. Somewhere I'm messed up. Okay, so 9x to the negative 2 over negative 2. So negative 9 halves over x squared from 1 to 3. So that's negative 9 eighteenths minus a negative, so that's plus 9 halves. So that's negative 1 half plus 9 halves. There we go. That's 4. Okay, so this part equals 4. Equals f of c times b minus a. So 3 minus 1. So 4 equals f of c times 2. Divide by 2, and f of c equals 2. But what is f of c? It's this right here. So 2 equals, f of c means plug c in here. So 9 over c cubed, cross multiply, and I get 2c cubed equals 9. That means c cubed equals 9 halves. And take the cubed root of both sides. C equals the cubed root of 9 over 2. So that's the value of c. Okay, number 13. Find the average value of the function. So we should know what the formula for average value is. 1 over b minus a times the integral of a over b of my f of x. So 1 over 3 minus a negative 3, so 3 plus 3, from negative 3 to 3 of 9 minus x squared dx. So I have 1/6. When I integrate, I get 9x minus x cubed over 3. And I'm evaluating from negative 3 to 3. So 9 times 3 minus 3 cubed minus 3. Now I'm going to plug my negative 3 in. 9 times negative 3 minus negative 3 cubed over 3. 27 minus 9. Negative 27. That's going to be 9. So minus negative 9, that's plus 9. 27 minus 9 is what, 18 minus negative 18. So that's positive 36, but I can't forget to bring that 1/6 down. So 36 times 1/6, and my answer is 6. Now another way I could look at this problem, we should know that 9 minus x squared is this parabola up 9 units pointing down. That's an even function. So instead of going from negative 3 to 3, I could have evaluated from 0 to 3, found this part of it, and then multiply my answer by 2, double it, and then take a sixth of it to find the average value. Okay, number 14. 14. Okay, anytime we have absolute values, then we need to see what this graph looks like because I need to separate this into two separate integrals. We should know that when I graph this from 0 to 5, okay, 0, 1, 2, 3, 4, 5, okay, that this is going to be shifted to the right 2 places. Okay, when x is 1, 3 times 1 minus 6, I get negative 3, but the absolute value of that. So when x is 1, I get 3. When x is 0, it's 6. So it starts off up here. And then when x is 2, I get 0. So it actually looks, that's horrible. Okay, this is a V. All right. So I'm actually finding the area of this and the area of this. If you want to find that by using the area of a triangle, then you can do that and add the two areas together. Or I'm going to break it up like this. Okay, so here's how I'm going to write my integrals. I'm going to say from 0 to 2. Now, if you notice, this line has a negative slope. So I'm going to say the negative of that equation plus the integral from 2 to 5 of 3x minus x dx. So I'm going to distribute this. This is actually negative 3x plus 6. So that's going to be negative 3x squared over 2 plus 6x. And I'm going to evaluate that from 0 to 2. And then I'm going to add to that 3x squared over 2 minus 6x from 2 to 5. Okay, now I'm going to let you guys plug those numbers in, and you should come up with the area of that. Okay, and then the last two are bonus questions. We'll talk about those in class.